Let's continue by implementing the main business logic. We create a new Swift file in our business logic folder or group and call it Pomodoro Timer. Before we start implementing this class, let's just add two enumerations. One we will call Pomodoro Timer state, and this contains the three states the timer can have, because it can be idling, so it's waiting for user interaction, or it can be running, of course, or it can be paused. You also want another enum, and this will indicate the mode we're currently in. So in Pomodoro you have periods of work and periods where you take a break, and we make an enum that depicts that. So we have case work, and I call it pause, because if we call it break, it will complain because break is a keyword in Swift. So let's just call it pause. Okay, let us implement the Pomodoro Timer class. What does it actually do? It has a timer that ticks every second. And it has properties that tell the consumer how many seconds left or have already passed. And it has a property that expresses the same thing in fraction of null to 0, to null to 1. We're going to use that for that circle. So if it's half full, the value will be 0.5, if it's full 1, if it's empty, it's null. We also will express the time left as a string, for instance, 10 minutes, 20, 42 seconds. Then we have public methods, and these just reflect the possible user interaction. So we have a play, a pause, a resume, a reset, and a skip action. And then we have helper functions that we are going to call. Let us just set up all the internal properties we're going to need to do our work in here. So we have those two things up here, the state and the mode. So let us add just two private properties. Timers mode, which is of mode at the beginning of work, and the state. Timer state, and we start with idle. Okay. Then we want the user of the class to tell us how long the work and the break timer should run. So we could hard code it to 25 and 5 minutes, which is more or less standard when it comes to Pomodoro, but we don't want that because that would make testing the UI a lot harder than necessary. So let us just add two more variables. One is the duration work, and we use a time interval because that is what the timer will expect for its duration, and another private var duration of the break, which is also time interval. We do not initialize these. To do so, we use a constructor, and we do that like so init, and we take the work in seconds as a time interval, and the break in seconds as a time interval. And now we can set these values. Seconds and duration work A equals work in seconds. Okay, let's continue adding a few more properties. So we will have to track how many seconds have passed, and we also want another variable that, as we mentioned up here, stores that as a fraction of 1. So let's add those two. We could simply increase the seconds passed each time our timer ticks, but we also would like the user to be able to pause, and if we do that, we cannot just continue counting, leave the application and come back, because the timer will not run in the background. So what we do instead is we introduce a date variable, which will always have the value of the time the timer was started. That way, we just look at the current time and at the date started, and we can calculate the numbers of seconds that have passed. There's one problem with that, however. So, what if the user pauses? We cannot just simply calculate the time from the very beginning of the timer, and now if he pauses in the middle, because that way the seconds pass will just increase, and not taking care of the fact that the user has paused. So we add another variable which simply stores the numbers of seconds that have passed before the user pressed pause, and we call that seconds passed before the pause. Okay. Asset timer, and we don't have one yet, so let's add that one as well. Just a timer of type timer, and we set that to 0. Let's continue with the methods, the play, pause, resume, reset, and skip method. Let's just go through what we have to do for each of them. So when we start, we can set the date started to the current date. And the same holds true when we resume after pausing. When we start, we can also reset the number of seconds passed, because at the beginning there's 0 seconds, and the same of course is true for fraction passed. We can't do that here when we resume, because we don't want to reset that. We can also set the state to running, and in here as well, running. Okay. In the pause method, we simply store the seconds that have happened so far in the seconds passed before pause, and all we have to do here is we take the seconds passed so far. Also, we set the state to passed. For the reset, we reset everything, that is, the seconds passed 0, the fractions passed 0, the seconds before pause also 0, and the state goes back to idle. Okay. Finally, the skip. Here we check what mode we're currently in. So if we are in the work mode, so if it's currently work, the next thing will be pause. So we change the mode to pause. And if the mode is pause, we set the mode to work. So remember, this is not pausing the timer. This is one of the two sorts of periods we have. We either work or we take a break. Okay. So let's use the timer here. So you might think that we just start a timer when we start this, but it's actually a lot better to start a timer each time we start counting again. And we do that when we start and when we resume. So we create a timer here and we create a timer here. That will make it possible to pause, save the seconds, pause, then on each tick just add them up. So what we need really is a method, a private method. Let's add private method here that creates a timer. So private func create timer. And we also need one that kills a timer. That is called whenever we pause or stop, that is reset. So let's use them. So in the start method, we want to create a timer. In the resume method, we create a timer. In the pause method, we kill the timer because we no longer use it. And in the reset method as well, we kill the timer. Okay. With skip, we don't have to do anything about it. All right. So we create the timer to create timer method. Don't have to comment that, it's pretty clear. Timer, and we use a scheduled timer with time interval and repeats. So the time interval is 1 second. We want it to tick every single second, and it's running continuously, so it repeats. And we pass the callback as a trailing closure. And this, actually, to be honest, I don't know what we receive here. It doesn't really matter because all we do is we just do something every second. What we do here is we call a method that we have not yet added, which is called onTick. So each second, this method is called. So let us add this quickly. Func onTick, and we will implement this right after we implemented the kill timer. Kill timer simply looks, do we have a timer? If so, invalidate it and reset it to nil. Okay. This is where the meat of our application is. In here we take care of all the values. On every tick we have to update seconds that have passed, and we have to take into consideration the number of seconds that have passed before we paused. So let me just write down in comments what we're going to do. So we calculate the seconds since the start date. Because each time we start or resume the timer, we have a start date and we can calculate the seconds and then add them to the seconds that we accumulated before we paused, if we paused. If not, it's nil. Then we do that, we add the seconds before paused. Sorry. If any. And next we calculate the fraction and set it. Then there's not much left to do but to check if we're done. So when done, we play the sound, reset, and switch mode. So from work to break to work, or pause as we call it. And we have to reset the timer. Okay, let's start implementing this. So first we calculate the seconds since the start date, and call this since start date. And we can do that by using the current date now, and it has a time interval since and any given date, and the date we want to compare it to is the date we started the timer. If we pause before, we have seconds before pause, and we have to add that to the total of seconds passed. So the total of seconds passed is that property, seconds passed, and we add the seconds in start date to the seconds before pause. Now, this is a double. This is supposed to be an int, so we have to typecast that to int. Next, we calculate the fraction equivalent of the seconds passed. And this is simply done by using the seconds that have passed and divide that by the duration. Now, we have a problem here. So we have two different durations, one for work and one for pause. So what we could do is we could do an if-else statement here, but we will need to have access to that value later again. So let's just do a computed property here and call it duration. So let's go up here and say, let's add the computed properties here. Computed properties. And we want to have a duration, and the other durations are of type time interval. So we have a var duration. Let's make that a private computed property. Duration is time interval. And if the mode is work, we return the duration work, else we return duration break. Let's go back down to our tick method. Again, this is supposed to be double, but the seconds passed is an int, so we have to typecast that to a double or a time interval. They're basically the same. And then we check if we are done. And we are done when there's no seconds left. So self seconds passed. The thing is, we don't want to check against seconds passed because that's counting up. So we need a property that gives us the seconds that are left. And we want to make sure that we stop the timer when this reaches nil. So let me just add seconds left here and check against nil. And now we have to go and implement that. And again, we're going to create a computed property. And let's make that public so we can use it outside if we want to. It's called var seconds left, which is an int. And this is nothing else but the duration as an int, the other computed property which is created, minus the seconds that have already passed. While we're up here, let's just add all the other computed properties that we're going to need because we want to access them from outside of this class. So we have the seconds left, and we also want the seconds passed. And here we can simply return seconds passed. We also want the fraction passed, which is a double. And we return fraction passed. And we also return the fraction left. And here since the fraction is a value between 0 and 1, we just subtract from 1 the fraction that is already passed. Okay. Let's continue with those computed properties because right now the mode and the state are not visible from outside either. So let's add this. Okay. Let's go back down to our onTick method. if seconds left reaches 0, so if the timer is done, we first want to switch the mode, and we already switched the mode in the skip method, so we can simply call that. So self-skip to switch mode. And then we want to reset the timer, because that one, if we go back up here, also kills the timer. So we get this done as well, the resetting timer. Then we want to play the sound, so let me just play ending sound. We'll add that later. And then we have to set the fraction passed also to 0. Could do that up here. This is just necessary because it not necessarily is 0 here. This calculation here might return something else than 0. And so we explicitly set it to 0 here when seconds left, which is an integer and can not be anything other than 0, 1, 2, 3. So we use that to set the fraction to 0. So let's just add that sound playing thing. We implemented our Pomodoro Audio class, but we do not have an instance of that yet. So let's add that here, audio, Pomodoro Audio, and we can instantiate it in here. Let's go back down here and audio, play, and we want to play the done sound. Now we also have that other sound that plays on every tick, and we can add this here before the if statement, play tick, and again audio, play tick. All right, I think that's almost everything. There's one small thing left. In the timer, we want to display the seconds left as a string expressed in seconds and minutes, or minutes and seconds. So let me just quickly write a method that does that. It takes the seconds as an int and returns a string. And it might return something like 30 minutes, 23 seconds. So instead of boring you to hell, this is nothing special. So let me just copy paste code here. So if the seconds is smaller than 1, we just return 0, 0, 0. We calculate the hours by dividing the seconds we have by 3600, which is 60 times 60 minutes. Then we get the minutes by dividing the seconds or modulo the seconds by 3600, whatever is left. We divide by 60, and the seconds we just take the modulo of 60 on the seconds. And then return the string. If there's more hours than 0, we return hours, minutes, and seconds. If not, we just return minutes and seconds. Finally, we're giving access to this output as a computer property. So let's move back up to our computer properties. And we have the seconds passed here. So we want a computer property that's called seconds passed as a string. And it returns format seconds, and we pass the seconds passed. And we also do the same thing for the seconds left. So seconds left, string is a string, and we return format seconds, seconds, seconds left. We have to use the computer property here because that's the only way we have it available. And while the cat was sitting in front of the door begging me to let her in, I realized we completely forgot to schedule the notification. And we do this when we create a timer. So down here, so create timer and schedule notification. Remember, each time we schedule a notification, we get rid of all currently active notifications. So this is exactly the right time to schedule a new notification. So we do Pomodoro notification, schedule notification, and as the seconds we use the seconds left. We have that as a computer property, but it expects a time interval, so we have to typecast this. And we give a title, timer done. Your Pomodoro timer is finished. Now might be wondering, how are we going to use that in a SwiftUI? Because we don't have anything published here. Well, since iOS 17, you really don't have to bother too much about that anymore. All you do is you decorate a class with observable, and if you want to have IntelliSense support, you just import the observation framework as well. What that does, it takes a good look at your class, and everything that's publicly accessible will act as if it was a state variable. That's really all that you have to do. Let us create a quick demo for the timer we just implemented. So we add a new SwiftUI view and call it timer demo. Okay. So let's just create an instance of our timer, which is a Pomodoro timer, and we give it 10 seconds work and 5 seconds break. Let us simply display 2 or 3 values that we expose as properties. Say the timer and the seconds left, and also the seconds left as a string. And yeah, let's also display the current mode we're in. So we have to open the raw value here because that's an enum. And we add a button that says start, and it just calls the start method of the timer. We only want to display this, however, if this timer state is currently idle. So, like so. For completeness' sake, just let us add a pause and a resume button as well. So if it is running, we can pause. If it is paused, we can resume. There we go. Before we run this in the simulator, we have to quickly hop over to the content view and make sure that our new timer demo view is displayed. So let's start the simulator. We can start the timer. It ticks. We can pause it. We can resume it. And once it's done, there will be a gong. And let's check if the notifications are working as well. So I start and then immediately lock the screen. And there we go. Notifications are working as well.